So if you have questions about the material for the midterm, now is the time to ask.
There was a question if consumer choice was going to be on the midterm.
Well, okay. Can you answer that question?
I believe not. No.
Yeah, like I thought I was pretty clear. No, it forms basis for a new separate midterm, but the everything we've covered so far will be on our first midterm. Okay. Is there another question? Okay. Honestly, it's totally fine to ask questions like that, for a little bit longer, because some people will be joining, and by the time we get to the main session, we may have some yet other people that come in and aren't clued in yet. And if anybody sees a question in chat that they feel like they can confidently tell the person, oh, no, this is, he already went over that. It's going to be the supply and demand, price controls and taxes and subsidies. That's going to be on our first midterm. Now, yeah, so are there questions about, because the thing is, if we're going to do this next week, our first midterm, and we're going to be, talking about this consumer choice fundamentals homework in the meantime, in between, well, at least by Thursday for sure, if you have any questions on this, the first set of material, then it's, time to get them answered. So we're in our review part of the class. So, okay.
So there's a few questions, but they're not regarding what's on the test. Is more, is it going to be during class time, or is the lecture portion multiple choice or short answer?
Yeah. So well, let me see, because I wasn't sure I understood that question exactly. But actually, I'm going to walk you guys through the exam. Remember, what we have planned for this Thursday, and I'm going to talk about it when we get to the main lecture, because I want to make sure that nobody's left out and everybody understands, the procedures for the exam. So if they're exam procedure questions, let's just hold off until 8:35, and then we can talk about the exam procedure questions. But if there are no substantive questions, then I'll go ahead and move on a little bit, and we'll talk about a few of these. So this should be pretty straightforward. And so actually, let's see, Abigail, are you here?
Hi, Professor. Yes, I am.
Okay, great. So why don't you take number 1?
Okay.
And Andres Estrada, Tellez, you there?
Yeah, I'm here.
Okay, Andres, why don't you take a number 2? Okay. And Celine Santizo.
Yeah.
How are you doing?
Yeah.
Yeah, I can barely hear you. I don't know if you can speak a little bit closer to the mic or something. Well, anyway, I can hear you. Take a number 3, okay? Okay, you got it. You're number 3. And Ben Garcia.
Yes.
Yeah, see, you're loud and clear, Ben. So you take number 4, okay? Okay. And I'll give you all I don't know, 5 minutes. I don't think that you'll need that long, but anyway, I'll give you It's 7:59. I'll give you to 8:05. Okay, see you in a minute. Okay. So Abigail, what do you got?
I got 26 bottles.
Okay. Let's see. Okay, very nice. Okay. And this is kind of a question for you, but is there any money left over, or does it go in evenly?
There is leftover.
Yeah. So we'll talk about this a little bit when we get to the main lecture, but this is where we actually, for the first time, hit the concept of goods that are discrete versus continuous. So like gallons of gasoline, right? You don't have to buy gallons of gasoline and whole gallons, but if it's a bottle of soda, you buy one or two, right? Or three or four. You can't buy a half a bottle of soda. So normally we would deal with goods that were continuous, even if they weren't, which means that we would talk about some general good like X or Y, or talk about widgets. And whenever we talk just in general terms, we're always assuming that the good is a commodity. And a commodity is something that is consumable in infinitely divisible units. So we would only ever end up with a whole number answer, kind of by coincidence or accident. So just to bear in mind. But anyway, good job. So, and Andres, what did you get for number?
I got
2?
19.
19. And for the same reason, right? And what about, let's see, number 3 on our list? This was Celine.
Hello.
Hi, Celine. Yeah.
I'm still working on it.
Okay. Yeah, and I think so. Here we got 1 and 2 are super simple, and then we got to number 3, and things got a little bit more complicated, right? Because this is a different kind of question. So do you have any questions about the question, Celine?
I just need to find the slope.
Okay. Yeah. Let's see. So number 4 was Benjamin. How are you doing on number 4, Benjamin?
So I think I have the idea how to solve it, but I don't think my equation is right.
Oh, well, that's kind of a problem, right? Yeah, because normally if our equations don't line up, then we're in trouble, right? So
I just want to make sure I'm like looking at this the right way. So basically we need to find like the equation from number 3 and we plug in the price of Zach's to get the relative cost.
well, see, so we're dealing with a couple concepts that we haven't talked about yet that we would, normally there's activity and there's lecture, but let's just go through this really quickly, because in the main lecture, I would bring this stuff up. But so let me do a new share and a whiteboard and share and go like this. And over here, we'll paste the question and try to move this stuff around a little bit. Okay, so this first one is about the slope of the budget constraint. We haven't really talked about a budget constraint. So generally the budget constraint is expressed this way. So you have, and these are interchangeable concepts. Sometimes you'll see income. Sometimes you'll see budget. And so there can be a bunch of different symbols you use. You could use I or B, or it's also common to use Y for income or budget. And then you have expenditure. So what the consumer is going to spend. And so your total expenditure, and maybe I should put here total expenditure, is divided in this case, there are only two goods. You could have an, countable number of goods, however many you want. There could be 10,000 or 50,000. So when we think about consumers' budgets more generally, you can think about using data from the Consumer Price Index. It would be a good example. So, but in our case, there's just two goods, and we're going to call one of them X. You could call it good one if you want, and you'll see in some of the questions and problems we talk about good one and others, good X. But that's the price of X is P sub X times X, the amount of X you buy, and that's how much you spend on X. And for Y, if that's your only other alternative, the price of Y times the amount of Y the consumer purchases is how much the consumer spends on Y. So if the consumer's only allowed to consume two goods, then if you add up what they spend on those two goods, that's their total expenditure. And so then the budget line or the budget constraint is setting income and there's a little bit of a difference here, okay? The budget constraint, formally speaking, says that your income has to be greater than or equal to your total expenditure. But for reasons that will be clear in a little bit, we assume that the consumer, in most of the stuff that we do in economics, we assume that the consumer will spend all of their income. So instead of an inequality, we say if they spend all of their income, then their expenditure has to be equal to their income. Does that make sense for everybody? Is everybody good? In particular, Benjamin and Celine?
Yeah, that makes more sense now.
Yeah. Now, Benjamin, I have got a question for you. Do you recognize, and I'll put a little X next to it. Do you recognize that form of an equation?
like a system of equations?
Well, no, this is just one equation. We have to have two equations to have a system, right? But this type of equation has a special name.
Ooh, I'm blanking on it right now. I'm not.
Yeah, well, do you remember seeing, like, you might probably saw an equation like this from you know, like when you're 8th or 9th grade. It's called a linear equation in general form. And so what you probably saw before was AX, which is A times X. I could put a little thing there, AX plus BY is equal to C. Does that look?
Okay, yeah, that looks more like.
That's a linear equation in general form.
Mm-hmm.
And the reason why I bring it up is, one, it should be familiar. College algebra is a prerequisite. So, but also so is 8th and 9th grade algebra. But you also might remember that we don't have to only represent linear equations in general form, right? What's the form you're probably most familiar with?
Slope intercept.
Right. And you know, we can do a little bit of algebra and transform the linear equation in general form into slope intercept form, right?
Mm-hmm.
And you remember how to do that?
Yeah, you just got to move around the variables and add and subtract.
Yeah, right. So in this case, if we were gonna write this one in slope intercept form, now a lot of people, I think, you know, it's kind of unfortunate, but it's true, is they remember slope intercept form is, you know, y is equal to mx plus b, and that's true, but notice we've transformed the coefficients m and b, right, in a way that if we write it just y equals mx plus b, we haven't really related them to the coefficients up here in the general form, right? So how does b relate to c and b and a in the general form, right? I mean, it's they do, but it's not like transparent, right? You can't say, oh, m is equal to this right instantly. So you see what I mean, Benjamin?
Yes.
Right. So we should do what you suggested, which is if we really want to make it match up, then we should have y over here, and I'll just do it in 2 steps. So b times y is equal to minus a times x, right, plus c. You agree with me so far?
Yes.
And then we just divide everything by b, and we end up with y is equal to, I'll write it like this, minus a divided by b times x plus c over b. And I guess, you know, like whatever looks better in terms of brackets or parentheses. But the point is that, you know, this is a quantity over here. So now, yeah, we know that m in our slope equation here is minus a over b, right? And we know that the vertical intercept is, which, and maybe it's better if I call this little b, right? Little b is, from our original equation, it's c divided by big B, right?
Mhm.
So now we know. And why do we put things in slope intercept form? What, I mean, is it just for fun, or is there a good reason for it?
I mean, I don't know if this is like the actual reason, but for me, it's just easier to kind of see the information, like what the slope is and what the y-intercept is.
Yeah, but why do you care about that information?
Well, I mean, like if you're looking at I mean,
Now think about it. You kind of said it. It's easier for you to see the information.
okay,
How do you see an equation?
on a graph.
Yeah, you graph it. The slope is literally the slope of the line, and the vertical intercept is where the line, right, has a point on the vertical axis. So if you have it in slope intercept form, it's really easy to graph, right?
Mhm.
You got a point and you know the slope. If you had graph paper, boom, right? So slope intercept form, I mean, maybe you didn't make the connection in algebra, or like, you know, maybe you just did it and you weren't like, you know, either you're copying something the teacher was doing, but you weren't thinking like, well, you know, like, well, why do people do this that way? Well, it is just because it's much easier to sketch a graph if you have the equation in slope intercept form.
Mhm.
If you do it, you know, from the general linear equation form, I'm not saying it's impossible, but it's kind of hard, because remember, when we're going to graph, right, we normally start this little like t-table thing, right, like this and
Mhm.
that, and then you calculate values of x and y that satisfy the line, right? And if you have it in slope intercept form, that's really easy. You just plug in a whole bunch of x's down here, right? I just plug in a whole bunch of x values and I get a whole bunch of y values out that satisfy the equation that are points on the line, right? Are you with me, Ben?
Yes.
I mean, do you agree, or you lose?
No, yeah, that's
Dr. Hunter, you don't know what you're talking about.
no, yeah, I agree.
I mean, you agree with me, and like this makes life easy if I want to, you know, plot points from this line. But here, right, on the general linear equation form, if I plug in an x, and then I want to find the y that corresponds to a point on the line when it's written this way, that's, I mean, right?
Mhm.
I mean, if, you know, I mean, you can do it, but I gotta, like, first I have to plug in the x, then I multiply it by the a, and then I still have by over here, so I still have to subtract off whatever I get on this side and then divide by b, the end result, and I got to do that over and over and over and over and over again, every time I use a different value for x. So anyway, yeah, this makes it easy to plot points. So the main reason I bring all of this up is that usually when you get a budget line, right here, right, remember, econ is applied math, so we deal with math and use it to analyze the things that we're interested in. Here, we are interested in modeling this budget constraint. it's kind of an assumption. I mean, if I was to tell you, okay, like, what do you know about consumers in general, right? And you were going to start making a list. I think you would pretty quickly come up with this idea, well, that they have a budget, right? It's just kind of common sense, right? And that if we're looking at how consumers spend money, then their budget matters, right? So how do we formalize that? Well, we write down some variable and we call it their income and their budget, and then we write down what they spend it on, their total expenditure. And that just gives us automatically this linear equation, because budgets really are linear, just, like fact of life. So we formalize that in an equation, and then we go ahead and we begin to analyze it. But once we've made that observation that led us to this general linear equation form, then the next thing that we want to do is we want to begin to visualize it. And so then the first thing we're going to do is we're going to put it in slope intercept form. And on Ignithium, you probably you might be familiar with this idea, but or this language. Do you know the y-axis has a general name, which is not the y-axis? Do you know what it's called?
Like
it's called the ordinate.
Okay, I've heard that, but it was usually of like the ordinate plane or something like that.
No, it's just called the ordinate. And you know what the name for the x-axis is? It's general.
No.
It's the abscissa. And you know why it's not the x-axis or the y-axis?
No.
Well, because guess what? X and Y don't exist in every language. X and Y are just arbitrary letters that we've decided to use as variables that in a particular instance we're going to plot on the ordinate or the abscissa. Like, when we're plotting lines before, we're plotting price on the ordinate, right? Remember, for demand, right, you have price on the y-axis and quantity on the x-axis. So we just label them as P and Q. Do you see what I mean? Y and X are labels that are commonly used in English speaking schools where people have decided that they're going to teach kids using Y and X as the general variables, but for math equations. But we don't, nothing says you have to do that, right? We just, like, it's a convention. So ordinate and abscissa are the general names for the vertical and the horizontal axis in a Cartesian plane, and we could label them whatever we want. You know what I mean? But we can still talk about the horizontal and the vertical axis without having to say horizontal and vertical axis. We can say ordinate or abscissa. I don't know if you think that's easier or not, but that's what people that do math do. So you can't say I didn't teach you anything today. So anyway, do you follow me, Ben?
Yes.
Yeah. So okay, so in this case, right, if we're going to transform this into a general linear form, then if we're going to make it look exactly the same with you know, a slope and an intercept this way, then we would have minus px over py, right? And I'll just write it this way, times x. Do you agree with me? I just moved px over the other side. And notice, like our general linear form, right? We have a c as a constant here. Now our constant's I. So can you see everything lines up?
Mhm.
You know, the only thing, if I wanted to make it look exactly the same, I could write it like this, is equal to I. Now we have it lined up exactly the same. And so plus I divided by py. Do you agree with me?
Yes.
Okay. So we'll go back to Celine. Celine, did you get the slope of the budget constraint? Because you were doing number 3.
I'm pretty slow, professor, so I haven't.
Well, okay, well, check it out. I just did it for you
Okay.
right there. Minus px divided by py. And notice in this example, you're given a py and you're given a px, right? Do you see, Celine?
I see it.
Yeah. So you have your calculator?
Okay. Should I say it?
Yeah, tell us. Let's drum roll, suspense.
Y equals negative 3.75x plus 125.
Well, I didn't ask you for the it's just the slope, right?
So negative 3.75.
You said 3.75. So px 8 divided by 30.
It's 8 divided by 30?
Well, that's what this says, is px divided by py, right?
0.266666.
I mean, do you agree with me or no? I mean, you see
Px. I thought the price of x was 30.
well, it says right here, p of y is
Okay,
30.
it's just okay.
I'm not trying to trick you.
I know that. I'm just a little slow right now.
Okay. Well, anyway, so you said your answer was exactly what? You can put it in chat. 0. whatever 2 whatever. So okay, let's see if we agree. This is the answer from Ignithium, and I'm gonna put it there. Is that right? You see it? Do you agree? You got the same thing?
Do we round it to 3 decimal places or just 2?
Well, you know, I say as much accuracy as possible is always a good thing on, Ignithium. But you should have gotten like, I mean, if I plug it in my calculator, what you have 0.2666666 or something like that.
Yeah.
Yeah. So, but it should work either way. I mean, if I'll tell you one thing, this is just for rounding error on Ignithium, right? That in general, I had one student that did tons of problems, and she told me that if she ever got to a place where there was a rounding error issue, if she carried it out to 4 decimal places, it went away. So accuracy is always great. So anyway, but anyway, I'll just see here. I'm just really curious. I'll let you know. If I put minus 0.27 in Ignithium, it says it's the correct answer. So that's 2 decimal places. So that's close enough. But 0.267 or 0.2666 would get the right answer too. Yeah. Okay. Do you have any questions about Celine? No? Are you good?
Not really.
Okay. So Benjamin or Mr. Garcia.
Yes, sir.
Yeah. So what about number 4? I didn't put the question up there, but
Is there any way we could go back to Ignithium very quickly? Because I thought I had the same numbers on my screen, but it's like I realized that they're a little bit different. I just want to double check I'm working with the right numbers.
Okay. Okay. There you go.
Thank you.
Yeah, actually, your numbers are a little bit different, right? Because the budget's different. So do you have an answer for us?
Yes, I have. Is it 57.67?
Well, okay, so tell me what, because you're interpreting now relative price, right?
Yes.
So what do you think the relative price is?
So what I did was I used that equation, the negative px over py times x plus I over py.
Yeah, okay, so I understand you're saying you use the equation, but you still haven't told me, like, conceptually, like up here, right, we have slope, and we know exactly what slope is because we just put it in slope intercept form and we found the slope. Boom, right?
Mhm.
Here, we should have an equivalent, like, concept that we relate to something in the equations, but it should still be a concept. So what's the relative price of Zax?
Well,
It's not like there's the price of Zax, right?
Mhm.
But what price is this? The price of Zax is 8. What does that mean? That means you go to the store and you'd give up $8 to get a Zax, right?
Mhm.
So have you ever heard of nominal prices versus real prices?
Yes.
What's nominal?
Isn't that like what it's supposed to be? Like,
No, well, nominal. So the word that when you hear the word nominal used in economics, it means the price in terms of dollars.
oh, okay.
Yeah. So nominal is always in terms of dollars, like nominal GDP versus real GDP. Nominal is always in terms of dollars. And what we're trying to do is differentiate between the concept of purchasing power versus the actual number of dollars you have to give up. So, for example, you don't know whether $8 is a lot of money or a little bit of money, right?
Mhm.
So do you ever hear your grandma or somebody say, "Oh, I used to go to the grocery store and I could buy a Snickers bar for a nickel"?
Mhm.
You ever remember that or no?
Yeah.
But was a nickel a low price or a high price for a Snickers bar?
I mean, for them, could have been like the same price that it is now, like with inflation and everything.
Yeah, so now you're getting to purchasing power, right? Because back then a nickel had a lot of purchasing power because wages, they had minimum wages that were like $2 an hour or $1.20 an hour,
Mhm.
right? So if a candy bar costs $1.50 today and the minimum wage is $15 an hour, then it still takes a tenth of an hour, right? So a tenth of 15 is $1.50, right? It still takes 6 minutes worth of working at minimum wage to get a candy bar. And if the minimum wage back then was, I guess it would, if it's a nickel, it'd be like 50 cents an hour, right? Then it'd still take 6 minutes to earn enough money to get a candy bar. So nominal prices, they on themselves don't tell us anything because you don't know what the price is relative to other prices, right? So it doesn't tell you how much of something like an hour's worth of work you have to give up. That's the most important um, real price in the economy is you take everything its nominal price, like I just did here in my example, and you divide it by the minimum wage to see how much time working you have to sacrifice or give up in order to purchase something. So it's really easy if the minimum wage is $15 an hour, which is not quite yet that. I don't know. Do you work a job or not?
Yes.
Do you earn $15 an hour?
No.
Yeah, see, like you're like my daughter. She works as like a lifeguard at the local pool, and she makes a little bit less than $15 an hour. But pretty soon in California, we're going to be at $15 an hour. But gas right now is like around a little bit more than $3 a gallon, right?
Mhm.
So how much time does my daughter, if gas is $3 a gallon, have to give up to earn a gallon of gas working at minimum wage?
Sorry, I know this is basic math taking me a little bit.
Well, that's okay. Um,
So like 15 minutes.
well, okay. So if it's 3, right? We know that 15 divided by 3, right, is gives us 5, or 3 divided by 15 is a fifth, right, or 0.2. So so if I take 3 divided by 15, I get 0.2. That means she has to work 20% of an hour, or 0.2 times 60. She has to work 12 minutes. Right?
Mhm.
So a gallon of gas costs her 12 minutes worth of work, or 20% of a work hour. And I got that by taking 3 and dividing it by 15. So here, if I want to say, well, how much of Zix, right, does this consumer Jocelyn have to give up in order to purchase a Zax, then again, it's going to be 8 divided by 30, right? And here again, they're stating it as a negative just because, you know, that's the convention they're using to show that you have to give up some Zix to get some Zax. Okay, my dogs are barking. But do you see, it's just 8 divided by 30.
Is that pretzel?
The little one is Pretzel, and the big one is Tasha. Come here, Pretzel. Come here. Hop up. Come on. Come on. Okay. Here you guys go. There's Pretzel. Okay. This is the culprit. The one who doesn't have proper Zoom meeting etiquette. She's the little barker. Okay, so Ben, are you good?
Yeah, so I just want to confirm that, like, when it's asking relative price, I don't want to say we're not comparing, but it's going to be like one of the goods divided by the other of the goods in the
Yeah, it's relative to the other good.
Okay.
That's what relative price is, right? So that's how we're constructing, you know, and this is the hardest part, I think, again, about transitioning from being trapped in the life of a consumer. You've been playing the game of the economic game in the role of, I'm somebody that goes out and buys something, but you probably think to yourself in the back of your head sometimes, when you have to make a choice, you're like, you know, I could do this. Like, so for example, we couldn't find one, but my daughter asked me, we just got the new Call of Duty Cold War. Anybody play that? Yes, no?
Yeah, I play it.
Yeah. So we just got that one because they had the free weekend, and then we had played the beta version, which I thought was better, but whatever. Then, like, at least the maps that I see on it now, we played the beta version and we really liked it. And then we signed on for the free weekend, but then we decided we wanted to unlock the zombies, so we went ahead and bought it. But it kept crashing on us, and my daughter's like, you know, Dad, we should just get a PS5. And I heard that they were sold out, but this was like, you know, around the holidays, so I thought maybe they would be back in stock. So we went ahead and we started to look up, you know, if there were any PS5s at Target, Walmart, or Best Buy or whatever, and they're all sold out, so it doesn't matter anyway. But it's about $500, and I was thinking to myself, right, like, well, I could spend $500 on PS5, but guess what? We also like to go skiing, and it costs about $500 for us to go and get our lift tickets and stuff like that. So if I'm gonna like plan a family fun time, right, and I've got a family fun time budget, I could say, well, I'm gonna sacrifice one, you know, ski trip for a PS5, right? You guys must do that. No, Ben, you ever think like, oh, if I buy this thing, I got to give up
Yeah, I mean, like,
two concerts because it's going to cost me, $125 for each concert, or I could go spend $250 on.
no, I mean, I did that like literally yesterday. I wanted to get a new like a Notre Dame hockey jersey, but then I was like, I really need regular clothes. So do I buy a $100 hockey jersey or clothes that I actually need for work?
Tough choice. So, right, you were using relative prices.
Mhm.
You see what I mean? You were saying, oh, I know the price of like this suit or whatever is this, or whatever you're going to use, dress shirts or whatever for work, and a hockey jersey is that. It's going to cost, I could trade in the hockey jersey for 3 button downs, right? And you calculated that because you're like, a hockey jersey is however much, and say it's 150, and each one of my button down shirts is $50. So you're dividing the prices, right? I'm saying, oh, for example, 150 for the hockey shirt, I mean for the hockey jersey, divided by $50 for the button downs, means I've got to exchange or give up, right, 3 button downs. 150 divided by 3 is 3. I've got to give up 3 button downs to get 1 hockey jersey, right? So you divide the prices by each other. That's the relative price. That's just what we did here.
And then I just want one last question. The whatever price is in the numerator, that's the price that we're gonna find, correct? So like say
Well,
for the price of
yeah, I mean, you're right. You have to think a little bit about interpreting this, because this is like just general. It's probably a little bit easier to construct the relative prices when you, in your mind, like hockey jersey versus button downs, whatever. Here you have to kind of say like, oh, okay, it's the relative price of Zacks. So you're always going to be dividing by the other things, right? So so what it's saying here, and it says pretty easy to interpret, right? If the Y good, the Zix, is $30 and the Zacks is $8, right? Then I've got to give up, like if I ask you, well, how much of the more expensive good, the Zix, do I have to give up? Like how much of a hockey jersey? I mean, you can't, the thing that probably messes with your head a little bit is you can't give up purchasing like a third of a hockey jersey, right? But again, we're assuming everything in most of our examples are commodities. So they're like bags of sugar that you can buy, it's like when you go to Whole Foods or something like that, it's in a barrel and you can take out however many scoops you want and weigh it. So a commodity is infinitely divisible. And so we're going to assume everything's commodities for most of the class, because then we can interpret things. So it's like things like, pounds of sugar or gallons of gas. So if this was like, Zix was like, a gallon of gas, and I know it's hard for you to think that a gallon of gas costs $30, but trust me, that's about what it costs in Europe. So, yeah, you could give up a third of a gallon, right? And this isn't exactly a third, but it's, a little bit more than a quarter of a gallon to get, a pound of sugar. So yeah, you're taking Zacks and you're dividing it by the price of Zix, and it tells you how many or how much Zix you have to give up in order to get 1 Zacks. So when you come up with a price, like this may be easier too, right? So in the nominal price, if I pay $8, I get 1 Zacks, right? So the price of Zacks is $8 for 1, right? Here, the relative price is, again, I'm gonna purchase a Zax. I'm gonna get one Zax, right? How much is that gonna cost me? Oh, it's gonna cost me about a quarter of a Zix, right? So the price usually tells you to get one Zax, I've got to pay this, right? Well, this is going to tell you too, to get one Zax, I've got to pay what? Oh, I've got to pay 0.267 Zix. Does that make sense?
Yes.
Yeah. Okay. Good job. And then the last person who I'll ask, because I think it was you that asked the question, was Michael Left, right? Who was like, oh, 5 and 6 opportunity cost.
Yeah, I was asking like, why is it negative?
Yeah, and so, you know, this is kind of a thing here, right? We could have used absolute value. We're relating all of this to the slope of the budget constraint. So we can interpret the slope of the budget constraint as being relative prices and opportunity cost of the good on the horizontal axis when we draw our budget constraint. That's the real connection we want to make. We got, notice, right? 3, right, is the slope of the budget constraint, Michael?
Yeah.
And then 4 is the slope of the budget constraint, and 5 is the slope of the budget constraint. It's just different language to describe the slope of the budget constraint. And so because we use the word cost here and we use the word price here, it's implicit we're giving up something, right, in order to get the good in question, which is Zax, and here it's Pax, right? We're giving up something to get Zax, right? Normally price is like we're giving up $8, right? So we're giving up something to get Zax. But so it would have been fine for these to be absolute values, but the only thing to, I guess, be aware of is the convention here that Ignithium is using, is they're using the slope of the budget constraint, and they're using the negative value to capture the idea that it's something being given up. But you could do it the other way, and like most people wouldn't argue with you. And in fact, I think there are a couple of places in the class, maybe a little bit later on, where we no longer use that convention of making sure we have a negative sign when we're talking about where we talk about you know, costs, because costs already imply that something's been being given up, right?
Yeah, so you're basically saying that like you're giving something up twice, right? So it doesn't really make any sense to say that you're giving up like a negative number if you're receiving something, but you're not.
Yeah. I totally agree with you, except for what we're talking about, you and me right now, is what I would call you know, semantics. And it's just important for us to know, for these questions here, the convention that's being applied. And you'll see this, like I said, in a little bit in like some other context where they kind of switch, and when we use the words cost or price, we talk about the absolute value, and you know, let the language of cost and price do the work for us in terms of you know, implying that there's something being given up. But I think that the point of the lesson right here is just to make sure that everybody makes the connection that we're really talking about the slope of the budget constraint. So anyway, that's the convention, and I won't defend it any more than I would any other convention, but it's important for us to know that, at least to make sure that we can get these questions right.
Okay. Sure. So anyway, I had another question.
Okay. Is it a question of substance on this homework?
Yeah.
let's see if we can answer it really quickly. Which number was it?
Oh, it's just more of a general question. Like, I was just wondering if you could explain like the copt equus utility function.
Oh yeah, exactly. So like I said, it's going to take us about 2 weeks to get all the way through this homework, and actually now we're going to go ahead and transition to the main lecture. So we may not get there till Thursday.
Wait, Professor, wait. So when's this homework due?
So this homework is probably going to be due on Monday, not of next week, but the following week.
Okay, thanks.
Yeah, it's going to take us just a little while to get through this. You'll see there are a lot of concepts that are kind of captured in this one assignment. It's a little bit longer than the other assignments, and there's some of the stuff, particularly at the end, that's going to take us a little while to get through. So anyway, okay, so I'm going to stop here for a minute.